question is asked in gate 22 of instrumentation. This is from network subjects. The question is, in the band pass filter circuit shown, R0 is 50 ohm, L0 is 1 millihenry, C0 is 10 nanofarad. The Q factor of the filter is. So basically, if you see, this is nothing but a series RLC circuits. And for series RLC circuit, the Q factor is having a standard formula, which is 1 by R into square root of L by C. The component value are given, just you have to substitute and you have to get the value of this. So 1 by 50 is the R values. So basically the notation R0, L0, C0 is used. So 1 by 50, L0 value is given 1 millihenry, so 1 into 10 power minus 3, and C value is 10 into 10 power minus 9. Take a calcium and simplify this, so this happens to be 6.32. So this answer is 6.32. So quality factor of a series R circuit, so by substituting the values, the answer is 6.32. This question is asked in gate 22 of instrumentation. This is from network subjects and from AC circuit topic. In the circuit shown, the load is driven by a sinusoidal AC voltage source where V1 is 100 at an angle 0 at 50 Hz, R1 is 20 ohm, C1 is 1000 by pi microfarad, L1 is 20 by pi millihenry, and R2 is 4 ohm. The power factor is. So one of the simplest approach in this case is, so we know like we can have the equivalent Z of this. So we can have the Z equivalents. So if Z equivalent happens to be R equivalent plus JX equivalents. So in this case, your power factors, okay, so it will be given by cos phi Z, that happens to be R equivalent divided by magnitude of Z equivalent. Because you know, like in the impedance triangle, okay, assuming positive reactance, if negative it will be downward. So if this is your R, this is your X, so this happens to be your Z, this length. So this is what is your power factor angle, phi Z. So cos phi Z is equals to R by magnitude of Z. So basically, I'll be trying to find what is the equivalent impedance. Then by substituting the values in this R equivalent and magnitude equivalent, we can easily get the power factors. So what is Z equivalent? Z equivalent happens to be R1 plus 1 by j omega C1. So not plus, actually these are in parallel, right? So sorry, this is R1 parallel with 1 by j omega C1. Okay, so this is in series with the inductor, so you get here j omega L1, and this is in series with the resistor, which is R2. Now if you simplify this, so this term happens to be R1 divided by 1 plus j omega R1 C1, right? Like R1 R2 by R1 plus R2, that way if you do, this is what you will get, plus this is j omega L1 and this is your R2. So now let us substitute the corresponding values of the components. R1 is given 20, so this is 20 divided by 1 plus j, and what is this omega? Omega is 2 pi f, f is 50 Hz, right? So in this case this is 100 pi, and R1 is again 20 and C1 is how much? R1, okay, R1 is 20, C1 is how much given? 1000 by pi microfarad. So this becomes 1000 into 10 power minus 6 if you do. So this will become 10 power minus 3 by pi, right? So this is what is the first term, plus again j into 100 pi is the value of omega, and L1 value is given 20 by pi millihenry, that is this much into minus 3, and R2 value is given how much? 4. R2 is 4, so plus 4. Okay, so this, if you simplify, this is 20 divided by 1 plus, you can see this pi and this pi will be cancelled out, and here this is 100 and this is 20 and 10 power minus 3. So you will get here j2 only, right? 10 power 3, 10 power minus 3 cancel. This is 1 plus j2, and plus this is j. So again your pi and pi cancel out. Again 2 0 1 0. Okay, this is also gone. So this is becomes simply j2, and then you have 4. So if you multiply the conjugate, so this is 20 into 1 minus j2 divided by 1 square plus 2 square, and this is 4 plus j2. So if you again simplify this, this is 20 minus J40 divided by 2 square, 4 plus 1 is 5 plus 4 plus J2. So 20 by 5 is 4 plus 4 minus J8 plus J2. So that happens to be 8 minus J6. 8 minus J6, right? So the Z equivalent value, we are getting how much? Z equivalent value is 8 minus J6. So if it is 8 minus J6, so if you simplify here, cos phi Z is equals to, so what is Z equivalent then? So Z equivalent magnitude, if I ask you, this becomes 8 square plus 6 square. 64 plus 36, 100, square root of 100 is basically 10. So in this case, R equivalent we are getting it is 8 and Z equivalent mod we getting it is 10. So 8 by 10. So that happens to be how much? 0.8. 0.8. And because you know, like you are getting a negative sign here, that means overall the circuit is behaving like a capacitive circuit. So if I ask you leading or lagging, so naturally it will be leading, right? So if it could have been positive sign, you would have said lagging. Anyway, leading, lagging is not asked, but in case it is, the perfect answer is 0.8 leading. So very simple. We have this a simple RLC circuits. By finding its equivalent impedances, we are getting its values 8 minus J6. Then power factor formula is R equivalent by magnitude of Z equivalent. So that's what is, square root of, if you find it, so square root of 8 square 6 square is 10. So power factor is 8 by 10 is 0.8. This question is asked in gate 22 of instrumentation. This is from network subjects and from the theorem topic. The given question is, given circuit A with current I1, I2 as shown, the current I3 in circuit B is dash. Okay, so such kind of questions we have seen multiple times with respect to reciprocity theorems, like where a circuit will be given initially, then some modification will be done to that circuits and we will be asked to find some response in that modified circuits. So here my idea will be, because what is the purpose? The purpose is to get the current I3. This is what is the current we expect. So my idea will be first to find this I3 using the superposition theorem, because there are two sources in this case. One is this 8 volt source, one is the 48 volt source. First I'll find what is this I3, this branch current because of 8. Then I'll find what is this current because of this source, and then I'll add it. But how to find that individual response? We may have to use some principle or some theorems in between. So now let me first draw this circuit. My idea is something like this. So this is what is my R naught, and now this voltage source is 8 volts, and then we have this 4, then we have this 8, then we have this R naught, and if I am finding the response because of 8 volts, so the 48 volt source, it should be short circuited. So this is R naught, this is 4 ohm, this is 8 ohm, this is also your 8 ohm, and this is your 6 ohm. This is your 6 ohm. Okay, and what is the current we are expecting? We are expecting this branch current, right? So this is what is the current we expect. So let's call this current is I3 dash. So the next circuit of interest is, so then this is what is the response because of this source. Then if I want to find the response because of this 48 volt source, then what is the corresponding circuits? So in this case, this 8 volt source, it will be short circuited. If I do that, the circuit should look something like this. This is your R naught, this is your 8 ohm, this is your 4 ohm, this is your 8 ohm, this is your 6 ohm, okay, this is your R naught, and this is your 48 volt source. Okay, so this is your 48 volt source, this is your R naught. And which current we need? We need this current. Okay, so this current, let me name this is I3 double dash. So I need to get I3 dash, I need to get I3 double dash. Then if you know this I3 dash, I3 double dash, so in this circuit, if I ask you what is I3, then I3 we can say this is basically I3 dash plus I3 double dash. This is what the principle of superposition is. So let's see how do you get this I3 dash and I3 double dash. Okay, so if you see this I3 dash, so if you compare this circuit with these circuits, this and this circuit, what is the difference? The only difference in this case is this is 16 volt source and this is 8 volt source. That means if I'm multiplying half into this 16, then this is what 8 it will be. So you know the principle of homogeneity. In a network, if you have a single source and if that source is multiplied by a constant k, then all the voltage current in the networks are also multiplied by the same constant k. That means if I am saying that if I am multiplying 16 with half, so that 16 into half become 8, then all the currents in the networks will be multiplied by the same constant half. So if I am multiplying 16 with half, so this current will be 2 into half and this current will also be 1 by 3 into half. So I need this I3 dash, right? And I3 dash is this branch current. So 2 into half, this become 1 ampere. Okay. So I got the first current I3 dash. So that is basically your 1 ampere. So this is based on the principle of what? Homogeneity. Now the next task is, how do I get the I3 double dash? I mean with respect to these circuits. So the idea in this case will be something like this. So let me do one thing. So in this particular circuits, so let me use the reciprocity theorem. Which circuit? In the first circuits. So what is the reciprocity theorems? So this is what is the excitation, the 16 volts, and the response is this current is the response. So this is what is the excitation, and this current is your response. So what is the reciprocity theorem says? So what is if we interchange the position of the excitation and this response? Okay, the ratio remains same. That means, so I mean to say, so let me draw this first. So in this circuit A, let me interchange the position of this 16 volts and this short circuit path. So how does the circuit look like? So this is your R0. So this 16 volt is replaced by short circuits. Then you have this 8 ohm. Then you have this 4 ohm. Then you have this 8 ohm. Then you have this 6 ohm. And then you have this R0, and then so the interchange source will come into picture. So this is how this circuit will be. R0, this is 8, this is 4, this is 6, this is 8, this is R0, and this source is basically 16 volts. So this 16 volt I brought here, and this short circuit I am taking here. So this is what the corresponding circuit is. Now, what is the consequence? If this 16 is resulting, this current is 1 by 3. If you are bringing this 16 here, that means, so this current will be your 1 by 3. That's what it means. If this voltage is 16, the response is 1 by 3. Then if you are bringing this 16 here, so the current in this path will be this current 1 by 3. That's what the reciprocity theorem is. But do you need the, so should I say I3 double dash is 1 by 3? No, because I3 double dash, if you compare, this source is not 16, this source is 48. But anyway, again, we can use the principle of homogeneity. If I know the response because of 16, then I can easily get the response because of 48 as well. So that means if I am multiplying this source 16 with 3, so this current will be also multiplied by the factor 3. So 3 into 1 by 3, so this happens to be 1 ampere. If this happens to be 1 ampere, okay, so what is I3 double dash? I3 double dash is defined in this direction. So this direction current is 1 ampere. So this direction current is minus 1 ampere. And what is this current? This is I3 double dash. So that happens to be minus 1 ampere. So I3 dash is 1 ampere and I3 double dash is minus 1 ampere. If I add both of them, so the overall answer is coming 0 ampere. Okay, so this is what is the answer is. So it is not a tough questions, but yes, you should have the idea of reciprocity and the homogeneity. Otherwise, you may not able to answer this question. But such kind of question is not new. In the past history, 2-3 times such model question has been asked. So where you have to use superposition, homogeneity and reciprocity together. Okay. So to summarize, first the current I3 was asked in this circuit. So I decided to get this I3 using superposition principle. That is, once I'll find the response because of 8 volt source, and then I'll find the response because of 48 volt source. So while finding the response because of 8 volt source, in the first circuit, the response because of 16 volt was known. By scaling it by half, I got this I3 dash is 1 ampere, right? Then in the second case, that is while finding this I3 double dash, in the circuit A, I have used the reciprocity theorems. So if this is 16, this current is 1 by 3. If I am bringing this 16 here, so this is what is the corresponding circuits. So this current is coming 1 by 3. But I need I3 double dash with respect to 48 volts. So that means I have to multiply in the source 3. So if I'm multiplying it by 3, so here also I have to multiply 3. So this current is coming 1 ampere, but I3 double dash is defined in the opposite direction. So this current is minus 1 ampere. So the individual responses are 1 and minus 1 ampere. The total response will be 0 ampere. So the answer is 0 for this. This question is asked in gate 22 of instrumentation. This is from network subjects and from AC circuit concept. The question is, a 1 kilo sine wave generator having an internal resistance of 50 ohm generates an open circuit voltage of 10 volt peak to peak. When a capacitor is connected across the output terminals, the voltage drops to 8 volt peak to peak. The capacitance of the capacitor in microfarad is dash. Okay. So this kind of question has been asked in last year in electrical branch. Almost same, only data is changed somewhat, I think. Otherwise, exactly same model. Let's see what data is first given and what we need to find. So first thing is, you see the statement. A 1 kilowatt sine wave generator having internal resistance of 50 ohm generates an open circuit voltage of 10 volt peak to peak. It means, so basically we have a source. This source feature, it's a sinusoid. Its frequency is 1 kilohertz. Its internal resistance is 50 ohms. Okay. And this is generating a voltage of 10 volt, peak to peak voltage. That means, so this is what is your open circuit voltage, right? So this is, let's say, if I am calling this is VOC, open circuit voltage. So this should be in the form of 5 sine of omega t plus some phase phi. So because if the sine, if I take the peak amplitude 5, then only the peak to peak will be 10, right? Don't say that it is 10 sine omega t plus theta. So it should be 5 sine omega t plus theta. Okay. Okay. So this is the first data. Then what is being given? When a capacitor is connected across the output terminal, the voltage drops to 8 volt peak to peak. That means in this given circuits, okay. So if the capacitor is connected, so this is a capacitor. So if this is the situation, then the peak voltage is 8 volt peak to peak. That means in this case, this is the capacitor voltage VC. It should be of 4 sine omega t plus theta. 4 sine omega t plus theta. That's what it means. So this is again your 50 ohm, and this is your again the same source. If I'm calling this is V in, so this is your same V in. So based on this, we need to find what is this capacitance C. Okay, so how do you get? So one thing is confirmed. So if I ask you what is this magnitude of VC, so magnitude of VC is 4, because if I ask you what is the phasor notation of VC, so phasor notation of VC is basically 4 at an angle of theta if I take sine as the reference. So if I ask you what is magnitude of VC, then it is definitely 4. So if I ask you what is this magnitude of VC expression with respect to this circuits, so that is given by magnitude of Z of C divided by 50 plus ZC magnitude into magnitude of V in. Yes or no? Magnitude of V in. Because we are only speaking regarding the magnitude. Otherwise, if you ask me what is the overall expression, so VC should be, it should be 1 by j omega c divided by R plus 1 by j omega c multiplied by this V in. So this is what is the expression. But if I speak regarding magnitude, if you take its magnitude, so this is what the same information I have written here. But what is V in? So one common sense is, so in this case, if I'm saying VOC is 5 sine omega t plus phi, don't you think this V in is the same as VOC? Because in this case, this path is open, no current is flowing, no drop is happening across this 50 ohm. That means this voltage will be definitely equal to this voltage. That means one thing is confirmed, that this V in is basically 5 sine omega t. Omega is 2 pi f, because the frequency is 1 kilohertz. So 2 pi into 1000, that happens to be 2000 pi t plus pi. This is what is V in is. So V in is, you can say this is 5 at an angle of phi. But if I ask you what is V in magnitude, so that happens to be 5. Okay. So this means magnitude of VC is 4. So 4 equals to magnitude of ZC is 1 by omega c. divided by 50 plus 1 by j omega c, 1 by j omega c magnitude. Okay, otherwise let me put mod here also by taking j, and magnitude of v in, we said this is 5. So this implies 4 by 5 is equals to, if I take mod, it is 1 by omega c. If I take magnitude here, this is 50 square plus 1 by omega c whole square. But omega value is 2 pi f, so that is 2000 pi. So this is a equation where omega is known, only c is unknown. So, like, we can easily solve this equation to get the value of c. So for that, what I'll be doing is, so let me square both sides of the equation. So this happens to be 4 by 5 whole square is equal, this multiplied by 50 square plus 1 by omega c whole square. This thing is equals to 1 by omega c whole square, right? So I have just square both sides. If I square both sides, so this will be squared, this will be squared, and this square root will go, right? That's what I have written here. Then you can simplify this. So this become 4 by 5 is 0.8. So 0.8 square multiplied by 50 square plus 0.8 square into 1 by omega c whole square is equals to 1 by omega c whole square. So that means if I ask you, if I take this 1 by omega c whole square as common, so this happens to be 1 minus 0.8 square is 0.64. So this is equals to, if you simplify this quantity, so this happens to be 1600. Okay. So that means 1 by omega is 2000 pi c. This square is equals to 1600 divided by 1 minus 0.64. Okay. So then this quantity, if you simplify, so this happening to be 4444.44. Okay. And if I take square root now, so that means if I take square root, so 1 by 2000 pi c, so square root means this will go, and if I take square root of this, so this is happening to be 200 divided by 3. That means what is c if I ask you? So c is basically 3 by 200 into 2000 pi, isn't it? And if you simplify this, this is 2.387 into 10 power minus 6 farad. So C is equals to 2.38 microfarad. So this is what is the answer. Okay. So the answer of this question should be 2.38. So very simple question. Okay. So indirectly the V in was given, and since the magnitude is of only interest, not the phase, so we have just drilled with the magnitudes. So we have written the equation of VC using voltage division rule and finding its magnitude. So this is what is the equation we are getting. Then by substituting the given data, just the unknown quantity C, we are simplifying the normal mathematical calculations, and it is giving us the answer 2.38. So 2.38 is the right answer for this question.